My name is Graeme Carter, and I am a senior manager for the Lab of the Future at Pfizer. My background is originally in chemistry. I qualified in pharmaceutical science back in 2005, and I have been working in the industry since then, in the pharma industry. I started in the QC laboratories, where I worked for approximately 3 years before I moved across to the LIMS team. And within LIMS, I would have built master data and configured analyses and specifications in labware LIMS. And since then, I've remained in the IT world, and I've worked on global enterprise solutions at a variety of companies, including Wyeth, Pfizer for a time. Then I worked for Amgen, and in Amgen I looked after all of the laboratory applications for their biomanufacturing site in Dunleary. After Amgen, I worked for quite some time at Novartis, where I ran the global chromatography data system, as well as being involved in support and service strategy programs and the Lab of the Future program as well. And finally, back around to Pfizer again, where I work again as the senior manager for the Lab of the Future team. Lab integration today is something like a rickety bridge, as you see it here on the screen towards the bottom. There are many temporary structures, although what we find often is that the temporary structures seem to last for quite a long time. Parts of this structure will occasionally fall over and not work anymore. And when you have monolithic systems, such as a great big LIMS that's connected with everything, if it runs into some kind of a problem, that can be traditionally the way that these things are set up, and it can be tremendously challenging. If something is to go down, it has knock-on effects on many other parts of your operation. What we envisage for Lab of the Future is something more like a connected cloud. And I particularly like this image because it's showing that every piece is connected to every other independently, but it also indicates that every piece is supporting the other parts. So rather than creating weak points, which can then have knock-on effects on many other parts of your operation, we create something that is self-strengthening. So these ideas came to be encapsulated in a manifesto, the digital technology-based capabilities for the Quality Control Lab of the Future, produced by BioPhorum in collaboration with several different companies, Pfizer included. It gives an industry-wide perspective, and again, to that point, there is wide representation from the business, from the industry. It's a realistic 3-year view with tangible steps to realization, published as of August 2020. And it leads on to the logical next steps and goals, which is to collaborate with your key vendors to help shape the vision. And that's a big one for me. I think we really need to be discussing this with our vendors so that they understand the industry as a whole is moving in this direction, and that they support it and prepare for it so that they can actually deliver what we need. Identify the key enablers is another next step. What do we need to do internally in order to prepare for this to happen, and form our roadmaps for change. Now, as to why things needed to change, there are several challenges in the industry, and I think the key statement on this slide would be that the quality control labs have fallen behind the digital enablement that we see in the manufacturing environment. So there are some examples given here. Test execution might not be automated because equipment in the lab may face limitations of control or connection. Technicians might use non-integrated systems, and so it can be quite difficult to get the data out of those, let alone move it anywhere else. Data might not be captured or shared automatically or consistently. We'll speak about that in a little bit, about what we are calling data dams and how the information is trapped within those dams. QC might not be an integral part of the manufacturing process. So something we see quite a lot in the industry is silos, where manufacturing and the laboratories tend to operate in quite independent and different ways rather than sharing methodologies and tools. Well, we all know that your data is at its most powerful when you have more of it together. And so taking a holistic approach across manufacturing and labs, it's a no-brainer. It should be the default approach that we take. So QC needs to catch up, but it also needs to integrate with what exists within manufacture. This chart, quite a detailed chart, It sets out the vision for the QC lab of the future. And the key thing to call out here is that while the vision and the manifesto sit at the top, beneath that there are realistic and tangible business capabilities, things which need to be delivered in order to realize the vision. And below that again, there's enabling dimensions, which will speak to the things we need to consider in order to have this lab of the future build out properly. Focusing on the capabilities for a moment, this is what QC is all about, the functioning of the capabilities. It speaks to the core business. So when we look at supply management, that covers everything that we do to get ready for testing. So it includes request and schedule management, sample management, materials and tech transfer, everything that you might do to prepare a laboratory for testing is included here. Likewise, under automated testing, this is the vision and something that we need to be thinking about. Where are we going? Well, ultimately, automated testing and some automated release is the direction we need to be headed in. Test output management, likewise, thinking about things like reporting, searching, data archival, having these things happen automatically and with limited or minimal or no manual intervention, as these things have an enormous overhead. If we could release people from those responsibilities, that's the direction we need to be thinking in. And everything that we build today has to support those activities in the future as we move towards them on a wider basis. To call out, for example, data capture, internal, obviously this is a key part of enabling automated testing or automated release. So real-time, automated, complete data capture in an open, structured format, not just a report layout, from any type of equipment, with instrument control through vendor-neutral, central solutions. So if you listen to all of those emphases, those are certainly things that are the future for QC, things that are to be achieved. And if we achieve those across all of our applications, that will certainly be absolutely transformational for QC. Again, to focus on the next underpinning level, the enabling dimensions, there are a lot of these that we need in order to support the development of the lab of the future. If you want that kind of integration and automation, you need to build a strategy for interoperability and for governance so that everyone works towards this one standard. As soon as you connect everything, you have to pay more attention, of course, to IT security, but not just the security, also the standards and protocols and ports and types of communication that you use needs to be a part of your architectural strategy so that everything will work along the roadmap that you have laid out, that you will get the desired functions and desired connections. You need to really lay down the roadmap for your architecture, not just for how you implement and use a system and how you govern it. How is it going to be built? What technologies should we seek out and what should we avoid? I think no small part of this comes down to people and culture. So of course, when you introduce all of these changes to technology and to data and bring all the benefits that the lab of the future can bring, that can mean that the job of the analyst, of the scientist, of the smart scientist who knows what they're doing, that can change. And this is part of the cultural transformation as well, helping the business to understand that in order to achieve the future that we would all like to achieve together, that there needs to be transformation on both sides of the fence, that as much as IT and technology changes, the job of people and the processes that people follow also need to transform. And IT has a big part to play in helping people to understand that transformation journey and how they achieve it, the benefits of it and the changes that it brings. So again, this is the full chart, which you can go through in your own time. It's available on the BioPhorum website. I do recommend having a look through this just to get some ideas of where you may need to hold some strategic conversations, who you might need to involve in setting up a program like this. This should give you some ideas on who you would need to bring in and what areas need to be tackled in order to deliver a Lab of the Future program. So moving on then to bringing the manifesto to life. So the wider this message spreads and the more that we move towards it together, the better it is for everyone in the industry. Also communicating this internally, talk about it with the various teams in your operating units, in your laboratories, in quality, speak about it with people in manufacturing, and share this idea as widely as you can. Sometimes something that comes from an external source that's been put together by multiple different companies can help to add weight to an argument, even if you are already making the same points. To show that the same points are coming from other companies and other people in the industry too can be very helpful. Moreover, this is a good structure, a good place to start if you haven't already started pressing these ideas. This can give you a healthy default way of starting to hold the conversation around the QC lab of the future. Now, going back to the chart for a moment, today we're going to speak a little bit about what Pfizer has been thinking about and looking at. We're going to be talking a bit about materials and equipment, talking about test description, test execution, data capture internally, quality management and analytics. Also, system integration and data integration, obviously a key part of what we all want to deliver. Moreover, the data analytics infrastructure, so data aggregation and analytics, how do we work on those and deliver those? Again, you could probably place a box around every single one of these because programs like this are so wide-reaching, but certainly we are focusing today on these topics. So within the Pfizer QC laboratory, there are some challenges remaining, but after great achievements, and I imagine most of you are probably in the same boat where you've done some great things within your QC labs, solved a few problems that were long-standing, brought the technology up to a good level, but are not quite at the stage where we want to be at in terms of the lab of the future. So just to call out some of the achievements that we've had at Pfizer, we've established some world-class enterprise standards, and those are being used extraordinarily widely. So there's been great success in rolling out these standards and deploying them. We have best-in-class security and data integrity in place within Pfizer. And we also have an ability to respond swiftly to demand, and that's a key one. You will be familiar with Pfizer's recent successes in bringing Comirnaty, the COVID-19 vaccine, to the market. And in no small part, everyone in the company played a part in making that happen. But IT also had its part to play, and our ability to swiftly respond to demand was a key part of that. So there's a terrific underlying foundation for success at Pfizer, and a great culture, which are things that are nice to be a part of. So they, in no small part, are things that are going to really launch us into success with our Lab of the Future program, as well as our other efforts. That said, of course, there are still some challenges, and I think there are challenges everywhere. So interfaces that exist are mostly one-to-one, one system to another. They're not following the same approach in many cases, where an interface for one system is of no benefit to another system. They're bespoke interfaces, which means they sometimes need some overhead in terms of maintenance, a little bit of TLC to keep them going. We also have data dams, where you've got this dry valley that is desperately in need of all of this this water to be released into it. So we don't have enough data in shared locations to make use of for powerful analytics. It's needed, but it's trapped in these locations. And sometimes that's a PC running an instrument, and sometimes it's a server, an application server, or data or database server. Sometimes it's a file share where the information is being kept, and it can be hard to link into those things. So this data is essentially trapped in these locations. But what we want to do is break down these data dams so that that information can start flowing into your data lake, and let all of that information come together. So some information is still hard to get at, being trapped in those data dams. There's still a good bit of manual work going on. So manual transfers for systems that aren't integrated, or transcription of data from one place to another. We also still operate a somewhat monolithic LIMS within Pfizer. It varies a little from location to location as to just how monolithic your LIMS is, but in some cases the LIMS system is doing a tremendous amount of the work in terms of data and management of data. We also have many sources of data. So as we just spoke about those data dams, the problem is not just the data being trapped behind the data dam, it's also that there are many of those dams that need to be broken down. So in order to pull together a meaningful report, often a lot of work can be done in plugging in the different sources of data from the QC laboratory. In terms of investigations, you can run across the same challenge. If you need results from 10 different systems to do a multivariate analysis on something with a product, a lot of work in that analysis is done in gathering the data that's needed for it, rather than in actually executing the analysis itself. So for Pfizer QC and our lab of the future, we are working towards eliminating all of those challenges, and we have a few guiding principles in place that we have looked at across the board. So the first one to call out is that we used to have a LIMS strategy, and now we have a laboratory strategy. So again, a monolithic LIMS, it can do a lot of things. It becomes essentially a weak point. Should it go down, then a lot of your operations are going to be affected. It's also reasonably good at doing a large number of things, but it's not perfect at any one thing. So it can be better to have a solution for a particular area rather than just putting everything into LIMS and making it do heavy lifting. The other problem there, of course, is when you make it do many things, you create an enormous master data overhead, where all of the master data needs to be built, qualified, maintained, updated, and this takes an enormous amount of time and resource and effort to do. When you build something that's a microservice for one particular purpose, it should do it flawlessly, and moreover, it should be a lot easier to manage than a module within a LIMS. So when you're putting something together like that, make sure that you are thinking about your master data and maintenance overhead, as well as governance, to ensure that it doesn't become so complex that you need hundreds of people to run it globally. It should be lightweight in terms of its management. So in order to deliver on what we've just said, we want to use things that are cloud first. Now, cloud first does not necessarily mean platform as a service. You can build things on your private cloud. But the benefits of cloud computing and the kinds of technologies that are available to you when you use cloud computing, these are the kinds of things that will truly enable the lab of the future. There's a principle here which is to avoid engaging anything that cannot use API. Now, that's not a hard and fast rule. Sometimes you'll find it's not possible. You need to use something that doesn't support the use of API. But if there is an alternative at all, even if it's an emerging alternative, then it's strongly felt that we should bet on talent and bet on the technology. The preferred approach would be to give people a single interface through which to access all of the suite of new applications that you're giving them, and have them almost unaware that there are actually different technological solutions working below what we've started to call the user horizon. So above the user horizon, they see this one system with a unified, harmonized interface where they can access the different functions that they need to access within the laboratory. Below the user horizon, you can have many different technologies supporting that operation. As long as you have API and you can call the functions of these underlying technologies and present them through a front end, then you can really minimize the training burden and the overhead of having to log into different systems and understand different systems. So that's a key principle for making this lab of the future easier for the user to adopt. Now, there's a point here that everything is connected, and I just want to emphasize here that everything is connected truly does mean everything. So we're not just talking about the technology interfacing and connecting with other pieces of technology. We're talking about having a program in place and a a project management structure in place, whether that be agile or whatever else, so that you involve everyone. And again, it's not just the business and IT and QA and risk management. It's one team, it's a lab of the future team that is working to deliver on this strategy. So the technology is connected, yes. The data is connected, certainly. The architecture and the infrastructure, those are connected, yes. The supporting teams, such as IT security, they are connected with what we're doing, of course. But so are the people, so is the culture, so is the governance, and so are the processes that guide us in this. Everything is connected. Another guiding principle for us at Pfizer is that we must fail fast and learn and iterate. So a lot of people just talk about failing fast and rapid prototyping, but of course failing fast is no good unless you learn from it and can quickly iterate as well. So fail fast, but also iterate fast. So keep building on what you've done, deliver some value, learn your lessons, then iterate and deliver more value and learn more lessons. I don't know what the best analogy is. Sometimes I think I compare it a little bit to NASA and the Jet Propulsion Laboratory when they were running the Apollo program, and they had to do something that nobody had ever done before. And if in that scenario people had been told that it was absolutely forbidden for them to have any sort of a failure, I don't think we'd ever have landed on the moon. Simple as that. They needed to try something. They needed to run an experiment, realize the problems with that experiment, and then design something better. And by doing that, by being permitted to experiment, by being permitted to have the small failure and to learn from it and then build something better again quickly, our development, mankind's development to put us on the moon happened so much faster and so much more effectively because those small failures were possible. So to talk a little bit about the projects that we're working on in Pfizer right now, without going into too much detail, applying the principles above, we are working on an execution system, which is not just like for the execution of methods. It becomes a single place for all activities and for the presentation of information within the laboratory to a user. We're working on an instrument hub for the transfer of data and also the management of instrumentation. We're working a little bit on our materials management, so management of standards and reagents, as well as safety within the laboratory, not storing things together that are incompatible or storing things in a location where they would be unsafe. We look at the tracking of locations and the chain of custody for things like controlled substances or materials of extraordinary value that we need to know who has them, not only where they are. Those are the kinds of things we seek to implement. In delivering these capabilities, we also look at how do we get data through the standard processes that we're enacting in these systems. How does that data get to the analytics portal? And I see sometimes differing approaches where people look at the transfer of data from one place to another as one task, and the transfer of data from a system to your analytics location as a different or separate task. Now, my recommendation would be to try to tackle those things holistically, not as individual tasks. If you can do that, you will greatly decrease the overhead that you face in providing data to your analytics platform. We also look at integrations wherever possible. We might transfer QMS information, so our quality management system. If you need to start an investigation, perhaps when you initialize it, some of the information that you would need in the investigation could be taken from your execution system and placed into that investigation. So rather than having to go and take notes and transcribe the identity of your instrument or the identity of the samples you were testing, those things could be made available in the investigation ab initio. So you find them there waiting for you. The data dam has broken. Previously, the information was trapped behind that dam, and now that we've successfully broken it down, it's flowing freely again. Something that occurs to me when we try to get information out of a location that's trapped in a data dam. It's a little bit like somebody standing on top of that dam with a small bucket, and they're trying to scoop the information out of it and pour it down to where it's needed for a report. And in fact, it's not going to be possible to do that with a bucket. If you stand on top of one of these gigantic dams and try to empty it by hand, it's never going to be effective. It's always going to be inefficient, and you're only ever going to get the current piece of information that you're looking for. Once the data dam has been broken, then that information is available at any time to anyone that needs it with appropriate control. So to return to the notion of everything being connected, we need to work with other teams. So if that's your data and analytics team, make sure that they have a seat at the table of this program. If that's your infrastructure and architectural teams, they need to have a seat here. Of course, your quality control representatives and your business partners need a seat at this. You also need quality, QA, risk management. Everyone needs to be involved here. There's a quality hierarchy. There may be, and there always will be, some variations from market to market. What a local regulator may require might vary slightly from what you find elsewhere. And so that needs to be allowed for. But overall, there needs to be an acceptance of the majority of a centrally validated and qualified system so that it can be rolled out to a new location with minimal additional effort. It also needs to be rolled out in as much as possible with the same basic configuration. The more customization of configuration that you do to suit a differing business process, the more management overhead you're creating for yourself down the line. That's something that we have with today's systems that would be preferential to eliminate rather than to create it again. And so that quality hierarchy has to exist. We don't want to create a solution that is one size fits none and doesn't allow any degree of customization. But at the same time, if you create something that varies wildly from location to location, the management of that system is going to become extraordinarily difficult, and it will probably not end up delivering on the data part of the program. Our data will end up looking different from location to location. So the idea there is that the buck stops somewhere. Someone has to make a decision where there are differing ideas and differing opinions on how something should be operated. There has to be a level of seniority where somebody can actually make that decision. And within what we would call a blue culture, where people do openly discuss and do not become authoritarian and do not become defensive, where we openly discuss our ideas, it's okay that there is someone there to make the final decision. That's all right. So that's the kind of culture that needs to be built. We discuss these things openly and freely, but there is a decision made at the end. Instrument selection and support is another piece that sometimes isn't thought of as an IT process, and it isn't. It's ultimately a business process. How do you select and purchase an instrument or a piece of software for use in the laboratory? But IT absolutely needs to be involved in that conversation. When we select the global standards, we should make them more attractive to the community by supporting them fully with data and analytic structures. So do you choose the instrument that is fully supported by the current lab of the future technology and the power that that brings to you, or do you choose something that's not supported by those and will be a standalone? And very quickly, the most rational decision becomes use the one that is supported by the lab of the future. And so we can help with this drive for the standardization of instrumentation, which of course itself helps with things like tech transfer, and our entire network can become more robust because things can move from one place to another more freely. Manufacturing program integration, we have already mentioned that we should not work in a silo. If there is an application that's in use within the laboratory that can be of benefit to manufacturing or vice versa, pursue those same technologies. Don't always reinvent the wheel. Use something that's already established and working in this way. The data lake concept is one that should be very familiar to people. But I want to emphasize again the idea that we shouldn't have more than one lake. We should have our manufacturing data and our laboratory data cohabiting. And this eventually means very powerful analytics that cover the entire story of a product from its inception to its release. The kind of not just reporting analytics, but predictive and prescriptive analytics that we would like to build. The more data you can feed into those things, the better and the more effective they will be. And finally, something that's key to what we're doing at Pfizer is the idea that we exist alongside and operate with site-side programs or programs that are going on in individual operating units. Very often the technologies that we're building will address the concerns and requirements that a single site is identifying. So we have to do a good job of communicating and ensure that everyone's aware of what we're doing. But at the same time, there will always be programs that are halfway through to completion or nearing go live that maybe cover a little bit of the technology that you're going after at an enterprise level. And so we have to build into our strategy how exactly we deal with those things, whether that be they get replaced eventually by the enterprise solution, or we allow them to operate that solution in the interim, meaning their need in this particular area will be less, so we can target the sites that don't have a solution and then come back around to that site later. Or do we cease and replace that solution straight away? There are different options, and I guess that will depend entirely on your own internal strategy for this. But it certainly is something that needs to be considered. How do we deal with things that are covering the same areas as our enterprise solution, but at a smaller scale? So bringing it back to the wider idea of bringing the manifesto to life, all the participants in BioPhorum have been working together on moving forward some of the foundational topics that underlie what we need to do here for building a lab of the future. So I'd like to visit a couple of those now. First of all, data integrity. BioPhorum did produce a data integrity paper in 2017, and off the basis of that, we've been moving those things forward. Now, it is a work in progress, but it's looking at some very key areas, such as dealing with legacy systems and equipment within the laboratories. Also, with integrated lab systems, the data integrity challenges are different when you have integrated systems from when they are operating in a standalone sense. So how do we tackle those challenges? Working with contract labs, something that happens very often. How do we work with contract labs who maybe aren't quite up to our technology standard level? Also, cloud systems for the laboratories. So data integrity and the cloud. Who is responsible precisely for what aspect of data integrity? There's also new and emerging technologies that need to be considered. So next generation sequencing, for example, for RNA testing within QC. What are those systems going to look like as they begin to emerge on the scene, and how do we manage their data integrity? These are important questions to be addressing at this stage as we build out the lab of the future. Now, beyond data integrity, we also have system integration and data integration, speaking to the architecture, the enablement of the motion of this data. So the analogy here that we use, it is like a multi-stage rocket. You cannot get into orbit with a single rocket. You need to launch, and then you shed some of the weight that you were carrying, and then you engage the next stage to boost yourself further towards your goal. So there is no one technology that is going to enable us to integrate every single lab instrument and deliver all of the benefits of that in a single step. So standard integration, plumbing and data structures are essential to escape the hold back of legacy diversity of technologies, but that is not the whole story. So the architecture underlying these solutions, the complexity of that architecture must be decreased, and we have to shed many of the existing customizations that are in place in order to achieve our full benefits. So like the rocket decreasing in weight by dropping off the boosters it used to use to get to a certain place, in order to reach its full potential, that weight needs to be shed, and we need to escape it while we accelerate ourselves even further. Many of us have achieved the elimination of paper by making data available to electronic systems. We have also achieved, quite probably, the transportation of data, maybe from one point to another, maybe with a bespoke interface, but we are at least capable of moving this information. And you'll see the little arrow here that says you are probably here. Across the industry as a whole, you might find specific products or specific areas that are exceeding this current standard, but not across everything, which is why the next point is the standardization of laboratory instrument data delivery and data formatting. So this will allow you to reduce complexity and streamline validation. Beyond that, enabling the control of instrumentation in a bidirectional sense. We can initiate tests, monitor tests, and change parameters on the fly, and that's going to reduce manual effort and increase our predictability and efficiency. And then we finally get to what we described earlier as interoperability. So when things are interoperating, we have different systems from different vendors that are operating together. Standard methods, plug and play systems that are using the same communication technologies, again enabling that architecture that lets us build the lab of the future into what it needs to be. IT communication layers are like postal voting systems. So we have forms with specific purposes inside of envelopes, and those envelopes are inside of vans. And the vans, we're all used to them. They're standard, they're secure, and they are efficient. But imagine that you had to collect those votes separately from each house, and every one of them was handwritten on paper and in a format that was chosen by the person who lives in that house. Well, that's a little bit like our laboratory communications today. Not quite standard, not quite secure, and definitely not quite efficient. So when we take a look at these different protocols that can be used for laboratory communication of data and information, you can look first at things like REST API or MQTT. And these are technologies that are very good at the heavy lifting of data. They can move data. They're not so good at enabling actions with data or enabling the data on arrival to perform a specific function. So there are other technologies that are quite good at those things. We have SELA2, a relatively new player in this area compared with OPC-UA, which has been around for quite some time. OPC-UA, of course, heavily used within manufacturing, a well-established standard, but also a very, very large standard with thousands of pages of documentation in terms of its use, whereas SELA2 is trying to achieve something a little bit simpler, but it is also very new and not very widespread in comparison with OPC-UA, but a very interesting technology nonetheless. Now, both OPC-UA and SELA2, they give you the envelope and allow you to define actions in transportation and on arrival, but they both themselves require things like animal or allotrope in order to provide standardization of the format. So to finish up for this talk today, what are the things that you can do with this manifesto? Help to formulate opinion and vision. So be an advocate for standardization, focus on the benefits, and educate people who are selecting instrumentation as well as applications within the laboratory. Help them to understand that they should be seeking the kinds of standardization, the enablement of these technologies, the API-enabled technologies, for example, that will let us build the lab of the future. You can partner with your vendors to help us get there. And again, multiple people from multiple major pharmaceutical companies pursuing these goals and objectives. Ask for it and point out that we are working to this standard framework established within BioPhorum. So don't accept the idea that there are no standards and no options. I think that's probably the most important point here. Finally, we should press forward together on these foundational topics. Defining common approaches benefits everyone. Working out realistic steps to the future together benefits everyone. You can get out of BioPhorum, you can get out of Lab of the Future what you put into it. And so by participating and driving towards this bigger picture, the industry as a whole can benefit, not just any individual company. So we will always have our own approaches to some of these areas, but the foundational topics, we can certainly agree on them and move in a direction that benefits everyone. So that's the talk for today, and that's the manifesto for the Lab of the Future. And I certainly would love to see everyone getting involved in this. I'd love to speak to you and hear about what you're dealing with. And in terms of moving this forward together, I think I would encourage everyone to get involved, join in, join the conversation, help move things forward. And with that, I think we're going to take it across now for some Q&A.